Hello?
Hello.
Are you alright? Yeah, guys?
Yeah.
Okay, so we given an array of numbers like 1, 2, 2, 1, 3, 4. Okay, so this is array numbers, yeah. And then we also given a k integer, yeah, like 2. Can we find any two distinct index? You know,
Two.
distinct.
2 and 2.
I haven't finished. Distinct. How do you spell distinct? Distinct. Yeah. Distinct means that unique. Yeah. Index.
Distinct. 3 and 4.
I and J. Such what? Array I equal array J, and also the distance. Yeah. Distance. Absolute value I minus J is smaller or equal K. Okay. Yeah. So we want to find out if we can find two index, two values, yeah, two values. So two different values, yeah, two different index, and the values is the same. For example, 2 and 2, this is the same. 1 and 1, this is the same, right? And the distance I and J, yeah, the index distance between them is smaller or like equal like K. For example, 2. So look, this one and this one, yeah. It's okay, right? We find it because look, 2 and 2, the index difference is 1 and the value is the same, so we can choose. Okay? Yeah, make sense? How can we do this problem? I mean, this is a simple array problem. So we want to find, as long as we want to find two index, well, you can do what? What we can do about it? About the index. We want to find out if there's index pair, right? I and J. So we can do what? Two pointers, yes, we can do pointers, but most intuitively, the I and J, we want to find the pair, we want to find such pair, index pair, I and J. So given there are n elements in the array, okay, so there are n elements in the array, so what can we do about it? What can we do about it? We can do what? The first thing coming to your mind is what?
Brute forcing.
Yeah, we can brute force. What's the time complexity if we can do?
Square.
N square, yeah, we talk about that a lot. And then the second approach, as you said, 2-pointer, yeah? 2-pointer works, yeah? But how can we do this 2-pointer thing? How can we do? I mean, the thing is that we want to find out if there are, we want to find out what? If there are two same elements, which the distance is less than K, right? Yeah, 2 or what, this one. So does storing the previous index help? Like some element. For example, like if I'm here, right? The previous index of 1 is not existent. So that's fine. So we store the last one, the last index for 1 is 0. The last index for 2 is none, but we store it, okay? Which is 1. Okay, now the second 2. We are at second 2. So what's the last index of 2? 1.
1.
Now I'm at index 2. 2 minus 1
1.
is less than 2. So we found it, right? So as long as we walk through the arrays and then keep updating the index for the last occurrence of that element, and then we can check along the way, right? So that way we can solve this problem, alright? So this time complexity, if we're going through that once, that'll be O(n) linear. It's much quicker than this O(n) square brute forcing, okay? And then the way you talk about the 2-pointer is quite interesting, yeah? It's the third method I'm going to talk about here. So let's say we want to find out, look, so look the K, right? So let's talk about, because we want to find out if there are elements within the same, within this K equals 2, right? The distance. So how about we just maintain a window of size K, right? So we maintain the size K. And then we move, right? So we use the set to store all the elements in the K size window, and then we just maintaining that, and then we just shift it, moving, okay, and then we check if this element is in the window, okay, yeah, Okay, so let's quickly write down the 3 approaches. Yeah. The first approach, brute forcing. You know, for the brute forcing, it's quite simple. Yeah? Let's say check duplicate. This array, okay? And then first of all, we want to find out the length. Length is length ARR. And then we just go through how do we brute forcing. For I in range n, right? And then for j in range, you can start with I plus 1 till n, or you can iterate we can iterate the j up to I. It doesn't matter, okay? So either you have this ij pair or ji pairs, and then we just check if ARR I equals ARR j, yeah? And okay, so now this j is less than I, so I minus j is smaller or equal to k, then return true, right? And if we can't find it, return false, yeah? Simple. Anyway, right. You see, this brute forcing is quite intuitive, right? Look, intuitive, yeah? There are n elements in the array. The I index going up to n, the j index going up to I, and if the both elements, because I and j are different, right? Look, I and j are different, distinct. And if I equal and I minus j, because I is bigger than j, I minus j is smaller than k. Why do I not put the ABS here? Do I need to put the ABS here? Do I need to put the ABS? What's ABS?
Absolute
Value.
yeah.
But now I know I is bigger than j, so ABS I minus j is the same as I minus j, right? Yeah? It's a positive number, I know, so it's return true, otherwise return false, okay? The first approach, okay? Now the second approach. Define, okay, I'm not going to write the define, okay? So now I have a position. Position is a dictionary, okay? I'm using this dictionary to store the index for the element. The last index of the element, okay? So now I for the index, the value, index value in enumerate, okay? What's enumerate?
Or the group knows how much time they have there.
Index,
Yeah.
index, enumerate of the
Like,
array.
Index like 0, 1, 2, 3.
Yeah, index and value.
Value the
Yeah, we're done. Okay. Now look, if the now this value, yeah, if this value appears before, right, in position, and also its value, its index, right, its index is v, position v, yeah. But now the index is I minus position v is smaller than k. Then we return true, right? Now we need to put the, so we want to put the index I for the value v. So we do what? Post v equals I, right? And then return true. Okay, you see? Alright. I index, v is value, enumerate array. Okay, and then look, the value has appeared before, and its index, because it has appeared before, the index is position v, right? And the current index is I minus position v is the distance. If it's smaller than k, return true. Right? If not, I need to remember the index for the current value v. So I do this, position v equals I, return true if we can't find it. Okay. Ryan, is that okay, Ryan? Okay. The time complexity, ON, right? We're just going through once. Space complexity, yeah.
Yeah.
What's the space complexity?
And
We're done. We're using a hash stack. This is not hash stack. This dictionary, hash table. Now the third method. The size. Okay, let's do this. Okay, I'm going to write it here. So for we have let's say we have
employee.
So we want to store this data so in a hash table. Okay, we want to use the hash table to store hash set to store the numbers in a window. So let's say data equals set. Now the same for I v in enumerate. Okay, this is the same. Enumerate. What's enumerate in English? What does it mean?
I don't know.
You don't know. Enumerate. What does it mean?
Enumerate means enumerate.
Okay, that's a very good answer. Yeah. Enumerate means enumerate. Okay. Okay. Now look. So now look. If I is bigger than k, okay. If I is bigger than k, then what do we do? Because now, if bigger than k, and then I need to remove. We need to remove the. Now look. This is the k size. Yeah? This is a k size window, right? If I is bigger than that, if I is here, then I need to remove this from the window, right? So now I just need to do what? Data, so remove, I need to remove ARR, I minus k minus 1, okay? Right? That's this element, I minus k minus 1, falls out of the window. Right? Look, just imagine we have a window, moving window, size with k, and moving. So when I moving, then I need to remove the element here outside the window, right? That's what it does. And then now I just need to say if v in data, if we still have this data, v in the data, then we return true. Right? Then otherwise we just data dot add v. Okay, and then return what? Return false. Okay? What's the time complexity if you look at this if you look at this problem? Alright, right? What's the time complexity? Right, alright. Because look, we assume we're going through the element, right? What's the space complexity?
When
We are using the data. Do you understand this approach? Look, let's come on. I'm going to write an example, okay? Like 2, 1, 3, 2, 5, 6. Okay, this is the array. And then we are looking for if we can find two same elements when the index is smaller than what? 3. Smaller or equal than 3. Okay, k equals 3. Array is this number. Right? So this is simple, yeah? The first approach, proof of thing. Yeah? I, and then j here, j moving. I, j, or the other way is what? I, j. So basically we are proving the pairs of ij. This is easier. Yeah, we don't need to talk too much about it. It's slow, it's intuitive, it's straightforward, right? It works if the data, if the number of numbers is small, right? So we can prove it. Yeah. How do you say the number of numbers? Do you have a better way of saying that?
No.
The data set is small, right?
Okay.
Yeah. This one, the second approach, we're using this hash set, the dictionary, the table. The hash table. So we're using hash table to remember the index for the previous numbers. Okay, so now look the position, yeah? Now 2, we are at 2, right? I equals 0, v is 2. If 2 appear before? No, right? So I put it here, position 2 equal, the index is 0, okay? Now, Eric, look, this is position. Okay, position. Okay, now is 1 appear before? No, right? So I put it there. 1 position is 1. Is 3 appear before? No. I put a 3 position is 0, 1, 2. Is 2 appear before?
Yes.
Okay, what's its value? 0. What's current index? 0, 1, 2. 0, 1, 2, 3. Yeah? 3 minus 0. Less than equal than 3. Return true. You got it? Yeah? You got it. Okay, now this approach. I'm a set. Yeah? A set contains stores the unique numbers. Yeah? set. Okay, so for example, set data equals this empty. Data dot add 1 is 1. Data dot add 2 is 2. Data add dot minus 1, minus 1. Data add 2. Data dot add 2, what happened? Here, if this is data dot add 2, what happened?
You'll add 2.
No. 1, 2, minus 1. Now this is a set.
Yeah.
If I adding another 2, what happened?
It's repeated.
It's already there, so what happened?
So we
Ignore it. Yeah, we just ignore because set contains only unique number. It won't make a difference because 2 is already there. That's a different set. Yeah? It doesn't store the duplicate, it stores the unique element, so it doesn't matter. Okay, let's do this data. Okay, now IV. I is 0, V is 2. Right? If I index, this index needs to be bigger than what? Than 3, yeah? What's the, yeah, K equals 3, yeah? 0, 1, 2, 3, here. So when the index is here, we need to go into this, right? Otherwise, we just do it. We just don't, okay? So, okay, probably this is not a very good example because the duplicate value is here, even before the window, okay? 0, 1, 2, 3, okay? Okay, so this is the window, size window, so you're already there. So look, if V in data, no, then I do this 2, 1, 3, this is the data. And then 2 is already in data, so I return true, okay? So probably I need, if I remember, I move these 2, 2, 3, okay, and then K, let's say K equals 2, right? K equals 2, and then this way, K equals 2, then, no, then it can't find any, okay? 3, 2, then in this case it can't find it, okay? Now data 2, 0, 1, 2, so I needs to be here to allow to entering this, right? I bigger than K, okay? If V in data, no, data is empty, data at the beginning is empty, okay? Data dot add 2, okay? Okay, 1 is 1 in the data, no, so I add 1. 3 in the data, no. Okay, now here, look, we are arriving this point. It's more than K, right? It's more than K. So we need to remove these. We need to remove this from the set. So I remove it, and I check if 2 is in here. It's not, right? So I should remove it because this value is already 4. It's already far away. So we need to remove it from the set, from the window, right? And then I need to add it to here. Okay, again. Now I need to remove 1 from the window and add a 5. Then I need to remove 3 from the window and add a 6. So at any time the data stores the elements in the case, right? So why is that? Because the numbers in the set, in the window, is less than K steps away, right? So then we can check if it's in the data, then return true, right? This is quite obvious. Otherwise we add it, right? So every time we remove this, what's this? What's this number? What's this number?
I minus K minus 1.
So I'm here, what's this number?
That's 2.
Yeah. I'm here, what's this number?
That's 3.
I'm here, this is 1. What's here? I'm here, what's the number to remove? If K equals 2.
2. No, 2.
Huh? K equals 2, what's the number? The I minus 2 minus 1, what's the I minus 2 minus 1? Yeah? So what's this window about?
1, 2.
What I'm asking is that I'm at I,
Yeah.
and K, this data store the data stores the numbers within the K step. So I have to remove this number. What's this number? So I'm here. What numbers I should remove from the data? I'm here. What numbers should I remove data?
2.
2. Yeah. I'm here. What number should I remove data?
Nothing.
Why is it nothing?
1.
1. I'm here. What's the most? What's the number I should remove?
3.
Yeah, exactly. Like you see, because look, it's like a train moving, right? This is a size k. When I move one step to the right, so this is the number I need to remove it from the window. Am I right? Yeah? Make sense? Yeah? Okay, Ryan, does it make sense? Okay, so which one you think is better? Is the best? There are 3. Blue forcing, this one.
Definitely not blue forcing.
That's the very good answer. But how about these two? Which one do you have preference? Or you say it's the same?
The same.
It's the same because it's the same, yeah. Just different way of thinking. Yeah? This is use the hashtag to store the numbers with the window k, size k. This one will remembering the index of last appearing, the number, yeah, the last index of the number, and we can just do the calculation. Okay. And this one because look, because the data, yeah, the numbers in the data are less than k, less or than equal k. So I don't need to do this. I don't need to do this. I minus. I don't need to check the index here because all the index in the data, all the numbers in the data are k less than k, less or than equal k. So I just have to check the numbers in there, right? Okay. So this is 2 way of thinking. Okay. Little bit for today. Good job. Bye bye.
Bye.
Bye bye.